Okay, there we go.
All right. So today we're going to do a new topic. What we're going to talk about today is energy. Energy. There's a few different ways that I want to talk about this. Okay? First off, what is energy? You eat food, you get energy. You do things, you get tired, you lose energy. Energy comes in all different forms. Okay? There's all different types of energy. But basically, energy refers to the ability to do work. The ability to do work is energy. What is work? Washing dishes? Well, okay, sure, it is work. But it's more than that. Work, in a science sense, is anytime something moves. Work refers to movement. When I raised my hand, I just did work because I took this weight from here to here, so I did work. Anytime something moves, you had to use energy to do the work of moving it. That's how we're going to think about this. So there's all kinds of energy. Let's put some sources of energy that we commonly use. Okay, what can you think of? One is, of course, food. Energy for us. Another one is electricity. That's energy, right? Because it can do work. How about diesel? Gas? That's energy. It does work. Any other forms of energy you can think about? So, the way to think about this is these things are stored energy. There's a circle of life, a rhythm of life. Okay? All energy ultimately comes from where? We've talked about this before. Where does all energy on Earth come from?
The ground?
No. Not quite. No. Energy itself. There's one source of all of our energy.
The sun?
The sun. The sun is a massive burning spot of energy. It is shooting to the earth where we live. We feel it when you walk outside as heat. You feel it on your skin. You're feeling the energy of the sun come into you, the heat. So, all of these things are essentially energy stored. The sunlight is the energy coming to Earth from the burning of the fuel that's in the sun. Just like you have a campfire and you stand around it and you get warm because the energy is coming off as heat and you feel it. The sun is doing the same thing. It's like God's really big campfire. It's the biggest campfire in the universe. Or it's one of millions, but so think about how we store energy. When God created the earth, He designed some very elaborate ways of storing energy. For instance, how about trees? Trees stand there and they put their leaves out and they soak up the sun. What happens when they soak up the sun?
They get energy?
They get energy. Where do they put the energy?
Into the ground?
No, into the wood.
Into the wood. You know what this chair right here is? This is sunlight. This wood is created because the energy from the sun came down, the tree soaked it up. The tree used the minerals in the ground and the energy of the sun to produce this wood. This is sunlight. It's amazing to think about it that way, but it is. When you eat eggs this morning, they're going to give you energy, right? You're hungry, you eat, you get energy. What are you doing? So, yeah, the sun sends its energy to the chicken, which combines it with its food to make eggs, which we eat, and we get energy. Let's finish this little track here. The sun shines on the trees make wood. How do you release this energy? How do you feel the sunlight that's stored in there?
You burn it.
You burn it. If you start a fire, you get heat, which is exactly what was stored. See the circle? So this chair is actually stored sunlight that you can release. It's in its stored form. You can release it by starting a fire, by a spark. If you light it, it will continue to burn until it gives up all of its energy as heat and light. So believe it or not, when you light a candle, you're watching sunlight. Because when you light a candle, what's it doing? It's taking the wax, it's burning it, releasing the energy that was stored in the wax from ultimately the sun, and you're watching a little bit of sunlight come out of that candle as heat and as light. So ultimately, any chain you write down here is going to always start at the sun, and it's going to end at something that is the same as sunlight. Usually, heat and light.
Doesn't it go to the plant before the chicken?
Well, it depends, because there's multiple here. It actually gets more confusing. To the wheat, which becomes food, which the chicken eats to combine and make the eggs. So yes, again, you have a chain. So my point here is all energy comes from the sun. And it becomes stored. We use bits of it. When we eat food, we use the energy from the sun to do our life. That's what makes our body alive and well. Well, let's talk about the simpler forms of energy. This is for us, for living things. Electricity. That little plug in the wall is energy. Where does it come from? How does it get here? Let's draw out
The oil.
the oil. That's one way. There's lots of different ways actually that they make this. It can be from oil, coal, wind, water, which actually is gravity. There's a lot of different ways to make electricity. You know the simplest way that you can make electricity is a generator. A generator generates electricity, right? What do you do when you run a generator? We hook our big generator outside to the tractor. What are we doing to the generator?
It's spinning.
It's spinning. We're moving it. When you move the right arrangement of wires against each other, that creates electricity. All of these things are doing that. They're moving something, an arrangement of wires to make electricity. So what you have coming out of the plug, the electricity is not in the plug. The electricity is not in the wires that come to the house. The electricity is created back at the generating plant that's doing the same thing that our generator outside is doing. There's a really big one. Most dams are built to create electricity. You know how they do it? They build a wall. The water falls over the wall. As it does, it turns something. That turning of something turns a generator, just like our tractor does. Exactly the same thing. So, it is from the sun because whatever they use is ultimately stored energy. If it's oil, oil is created by living things that died. So essentially, oil is stored sunlight. It's a liquid form of sunlight, a liquid form of energy. Coal is the same thing, but it's dry. Wind. How do you make wind? We should do a weather class soon. It's interesting. What happens, think about it, the oven. You open the oven door, what do you feel?
The heat.
The heat. It rushes out. You have wind. You just made wind. How did you make wind? It's really simple. It's hot inside the oven. It's cold outside the oven. Heat rises because hot air is lighter than cold air. So you made wind by a temperature difference. That's exactly what the sun does outside. The sun heats a spot of land more than a spot of land that has clouds over it. That air is hotter, it starts rising. That means air has to suck in from outside. We feel wind as the air sucks in from outside. So everything you look at, anything that moves, ultimately comes from the sun. So, back to electricity. We have all these different ways of creating it. This electricity is generated and sent down wires to our house. We plug an electric heater in, and what do we get? Heat and light, or movement. So ultimately, electricity is nothing but energy created from stored energy that was stored from the sun. Same thing. It's always the same line. So, this is how energy gets to us. Let's talk a little bit about what energy, how we use it. Let's pick one that we use really easy. Diesel and gas. This is liquid that has a lot of stored energy in it. Wax is essentially the same thing. You could say wax because if you have melted wax and you burn it, it burns. Anything that burns is stored energy. Now here's the point that we want to get to. When you release energy, you can do work. The point we want to make is that how much work you can do for the amount of energy that you release is something you want to think about. So, for instance, let's take 1 gallon of diesel. Here's a question. How much work can you do with 1 gallon of diesel? Interesting to think about. Huh? When you look at our diesel tank outside, there's 450 gallons of diesel out there. We can do work with that, right? We can put that diesel in the tractor and we can do things. So that diesel tank represents all the work that we can do by using that diesel. But there's a limit to it. That diesel tank's not going to last forever, right? You crank the tractor up and it's going to run for a certain amount of time. It's out of fuel. So this 1 gallon of diesel has a limited amount of work that it can do because it has a certain amount of energy. It's not infinite, it's not forever. There's a limited amount of what you can do with that. There is, when you get up to the higher sciences, you guys should read about this, there is ways to measure and express exactly how much energy there is inside of this diesel. There's math formulas that will tell you 1 gallon of diesel can generate X amount of work. We're not going to get into the formulas right now, we're talking about concepts, but know that there is a certain amount of energy here. And that energy can be released. But here's the funny thing. There is two things you have to think about. Even if you knew how much energy there was in that diesel, how much work you can do with that depends on two things. What is the efficiency of releasing the energy? Efficiency refers to how much you put in versus how much you get out. So think of it this way. I like to think of it like that. This is what efficiency does. So you're putting energy into a bucket. And you have spigots. Okay? One spigot is work. How much work are you going to get? If it was 100% efficient, all of the energy goes to all of the work you get out of it. 100% efficiency. So whatever you know, whatever amount of energy you know is there, based on its diesel, so that is so much stored sunlight, you can convert that. If it's 100% efficiency, it all goes into work. But nothing is 100%. You always lose something. When you convert forms of energy, these are forms of stored energy. When you convert that to active energy and then do work, there's efficiencies and it's never 100%. So you cannot get a straight line. So what happens is, this spigot is on and you're getting work out as you pour energy in, but you've also got other spigots. You're going to get a certain amount of heat leaking out. You're going to get a certain amount of light leaking out. And you're going to get a certain amount of byproducts. So you've got all these spigots on this bucket. Efficiency of any one of these is the measure of how much are they open. If your work is open all the way, and this one is just a tiny little hole, you get a little bit of heat for every amount of work that you get out. If you open this spigot more, you get more heat and less of something else. Let's say this energy is electricity for a second, okay? And what I did is I plugged an electric heater into the wall socket. Most electric heaters, the old-fashioned kind, they glow. What color do they make?
Red.
Red. You've got light coming out of the heater. I just opened the spigot a little bit and I got some light. But you also have a whole bunch of heat. So if you just think about that little electric heater you plug in, there's two spigots open. But wait, there's actually a third one. What's the third one?
Work.
Because something's moving. What's moving? Usually a small fan. So think about it. You plug an electric heater in. What you've really got is a bucket. And there's three spigots coming out. And all those spigots, depending on how the heater is made, there's a certain amount of light, a certain amount of heat, and a certain amount of work that's coming out. So you can't say that I'm going to use 100% of this energy to make heat, because you're not. The light is actually waste, because electric heater, you don't use it as a nightlight. You could. It's not a very efficient nightlight because let's say it makes 1% light, 98% heat, and 1% to run the fan. So you say the heat efficiency of that heater is 98% because I'm losing 1% of my energy to light. See how that works? I'm using this way, actually wouldn't. This is a really big fan, but you're losing a certain percent to the other things. All right? So it's never 100%. You're wasting energy. Anytime you use it, there's waste because you're opening more than one spigot. You can't have just one spigot open. So let's go back now to our diesel. we have 1 gallon of diesel, we know that it can do this amount of work because it's that amount of sunlight stored. That's a chemical thing. There's a formula, and it never changes. When you get down to how much pig food can I carry out to the pigs with that gallon of diesel, that's all different. Now you've got all kinds of spigots open. Because you know what the tractor does? Let's draw the tractor bucket. We're going to put diesel in to our bucket. We have 1 gallon of diesel going in. What are all the spigots that we can think of through the tractor?
Makes heat.
It makes heat. The engine gets hot. The longer you run it, the hotter it gets. So there's heat. Is that useful?
No.
Not so much, huh? I mean, in the winter, sure. It keeps your hands warm. But otherwise, that's complete waste. Gas engines, diesel engines, any kind of engines get hot. What that heat is a portion of this energy from the sun is being wasted as heat. There's another one, friction. You know what friction is? Friction is the resistance to movement, which is wasted energy. Inside of an engine, you ever wonder why we put oil in an engine?
Lubricating.
Why would you want to lubricate it? What would happen if you don't lubricate it?
It would wear out.
It would. How come? Because of friction. Anything that moves against each other has friction. If you have this briefcase sitting on the thing, I'm moving it. And it's kind of heavy. What if I put a 50-pound bag of feed on top of this and then try to push it? It's harder.
Slower?
It has more friction between the briefcase and the table. Harder to push. The more friction you have, the more energy you have to expend to get it to move. Because this is waste. Every engine has a certain amount of friction. You put oil in it to drastically reduce the friction. But there's still friction there. So part of this diesel is coming out as heat. Also, part of it is coming out to make the engine move. Just to get the pieces inside the engine moving takes part of the energy. What else can we think of? Do you know that inside the engine, those you hear the engine run, chung 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 chung. Every one of those chung chung chungs is an explosion. Explosions have what? They have light. You don't see it because it's inside the engine. But every time that diesel explodes, it makes heat and it makes light. So you have that going on. What else do you have going on? This is where it gets really interesting. If you're talking about doing work, like moving feed from one side of the farm to the other, that's the work we want to do. Now we've got all kinds of stuff going on. You have this thing called gears. You have let's make it kind of simple. We have speed. The faster you go, the more energy it takes to keep you going at that speed. You know why? Think about it. It is actually the same thing as friction. Because when you're moving, the faster you move, the more you have to overcome everything that wants you to stop moving. If you're moving uphill, you're actually lifting the tractor up that hill. When you come through a ditch, and you notice when you're driving through and you start going uphill just a little bit, the engine sound changes. That's because you just lifted the tractor. The weight of the tractor has to go with you. So if you go a foot higher, you just lifted 5,000 pounds 1 foot. That's why the engine slows down. You don't think about that, but it is. So if you're driving on straight ground it's going to take a certain amount of energy to go from point A to point B. But if point B is higher, now, in order to go up this hill, I had to expend enough energy to lift the tractor. So this path takes more energy than this path. Because in the process, you just lifted the tractor. You didn't know you did it, but it's no different than if you go underneath and put your hand under it and lift the thing up. You use part of the diesel to raise the tractor higher. You also have the question of how fast you want to go. Efficiency generally decreases as speed increases. So if you go from point A to point B very quickly, let's do quickly by arrows, as opposed to slow. Generally speaking, it takes more energy to arrive at point B faster than it does to go slow. The reason being, you have this thing called acceleration. In order to get to a certain speed, you have to accelerate. That means speed up. When you speed up, you're using energy not to move, but to move faster. It takes a certain amount of energy to do the movement to go from point A to point B. It takes a certain amount of energy to reach a certain speed. And the higher the speed, the more energy you've got to put into it. So if you're going to go from point A to point B in 1 minute, that is X amount of energy. If you're going to do it in 30 seconds, that is a lot more energy. Because you had to speed up. In one sense, you think, wait, I'm there faster, so the engine is running less, so therefore I'm using less diesel, right? But it doesn't work that way. Because it takes more energy to go twice as fast than it does to go at slow speed. And you waste more energy getting up to speed than you do by running less time. Otherwise, you know what would happen if this wasn't true? If you just go really, really fast at the gas station, you never run out of gas. It doesn't work that way. When you're low on gas in the car, what do? You drive slow, you drive careful, don't speed up, don't slow down, just constant speed. Because speed has a lot to do with how much fuel you use to get there. Speed is a waste. Unless you need the speed, it is a waste. There is something that we have to talk about that changes that, called gears, but we're not going to get to that today. So these are all things that are eating it up. Here's a funny one. You know that the tractor actually is a generator inside? You have headlights. Okay, that's interesting. How do I make the headlights burn? Ever think about that? How is the tractor making electricity to run the headlights?
The battery.
There is a battery. How come the battery never goes dead?
Because when it's on, it charges it.
Charges it. How do you charge? How do you create electricity?
With this hand.
Well, yes, but what's our path? You use the sun in the form of diesel to run the generator to make the electricity to charge the battery. Well, that's interesting. Doesn't that mean that if I have the headlights turned on, I'm using more diesel than if I have the headlights turned off? It's not free, right? If I could turn the headlights on and not use any more diesel, I just generated free electricity. Let's plug our house in. It doesn't work that way. So theoretically, if you have the headlights on, it's going to take you more diesel to do the job than with the headlights off. Isn't that interesting? So we've got this thing about if I'm driving over bumps, it's taking more energy. If I've got the headlights on, it's taking more energy. If I'm going faster, it's taking more energy. See all these things? Think about also, how about weight? if you're actually doing something with the tractor, like moving something from point A to point B, we're feeding the pigs. Here's the funny thing. If you have a gate, you have to go through. So we have a gate. We're going to drive the tractor. And we're driving up and we have a gate. Got to open it. So what are you going to do when you drive up to the gate?
Open it.
Yeah.
You could go through it.
You're going to have to get off the tractor and walk over and open the gate. What's the tractor doing?
Running.
It's running. What's it running on?
Diesel.
Diesel. If I have 10 gates to go through, and I have to wait every time because I have to stop, I have to go through the gate, and I have to start again. All of this wait time here, 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 here. The tractor is running, and the only thing I'm doing is wasting all of my energy. So why don't we just turn the tractor off? Why don't we drive up the gate, turn the tractor off? Open the gate, crank it up again, go to the next one, turn the tractor off. Which one's better? Should I turn it off? Should I let it sit there and run? I know that having a gate is going to cost me something. So which way is more efficient? Should I turn it off and crank it up? Or should I let it sit there and run? It's interesting to think about. What's the cost of, if I turn it off and then I crank it up to go through? What cost do I have there?
It starts it up again.
How does it start it up again? How do you start a tractor? In the old days, you had a little crank to start it. Now we turn a key. What is that key doing?
Turning it.
It's turning it. How's it turn it? There is an electric motor inside that pulls energy from the battery that you stored there earlier to turn the engine over to get it running. So it takes electricity to start the engine. So here's the real question you're asking. Does it take more diesel to recharge the battery from the starting than it does to let it idle before you drive through? So if you really want to work on efficiency in this bucket, that's the sort of things you have to think about. Okay, how long can I sit here and idle and use less diesel than if I turn it off and crank it back up? That's actually a tough one to answer, because you've got to know the efficiency of all these things to compare the two states. Generally speaking, the rule is somewhere around 30 seconds to a minute. If your wait time is going to be 30 seconds to a minute, then you're better off letting it run, because it takes more energy to start it than it does to let it run for 60 seconds. If you're going to sit there longer than 60 seconds, it's generally better to turn it off. That's about where the sweet spot is. But the point for today is this, and there's more. We can keep going. This is a big list. In this bucket, there's all kinds of spigots, and they're always running. To give you a real clue, we'll end on this. Generally, in a diesel engine, I think, in a really good diesel engine, I think it's somewhere around 60%. So, of that 1 gallon of diesel, almost half of it leaks out into all these things. Almost half. They're not very efficient. They're really handy, but they're not very efficient. So that 1 gallon of diesel, we figured out it can do a certain amount of work. It's a certain amount of stored sunlight. At the end of the day, what you're going to get out of it is probably around 50% of that stored sunlight. Is all that you're actually converting to work, because the other 50% is in all these other things. In the engine itself, in the way that you drive it, and all this stuff. So about half of that diesel tank out there, that 450 gallons, half of that, 225 gallons worth of it, is going to be used, making it possible to use the other half. And that's something to think about. The more you can do to make this more efficient, the more work we can get out of that 450 gallons of diesel. And that's where we want to end today, thinking about energy. Energy is the ability to do work to make things move. But it takes energy to use the energy that's stored. So, in the sense of like a diesel engine, you're only going to get about half. If you're really careful how you do it, maybe you can make the half up to 60%. So how you do things, you should be thinking about it, because this is money. It takes money to buy diesel. So here, if you can raise it from 50 to 60% by being more careful, you just saved 10% of the money. I'm sorry, that's not 10%. Yeah, it is 10%. You just saved 10% of the money. So if this diesel tank costs $10, think of it this way. If you have a tank of diesel that costs $10, and you can use that and be only 10% more efficient, you know what that means? You just saved $1 that you would spend otherwise. So you have an extra $1 that you wouldn't have simply by being more careful about how you do things. That's how quickly it works. If you do this every day, if we were doing a big job and we're burning a tank of diesel every day, and we could be 10% more efficient, how much would we save in a month? You're talking about $30. If you save $1 a day over a month's time, you just save $30. That's money that you wouldn't have otherwise. So you want to ask yourself, am I better to turn this off or am I better not? There's no real, it's hard to know exactly, to get exactly perfect. But you see, if you make the right choice here, you have an extra $30, where if you make the wrong choice, you don't. So that's how we need to think about things. Energy is the ability to do work, but every time you do work, there is an efficiency that changes based on how you do things. If you do it right, you save money. If you do it wrong, you waste money. Okay? That'll be it. I'm curious how this looks on our new camera.